Thanks for sticking with us. It's been a heck of a 15 months. Every battery's dead in my bag. Stuff isn't in there that was supposed to be. Like, we're all remembering another way to work. And yet things are different. They're still different. This is a full hybrid show. This is DEVintersection, both online and in person. I'm here. There's folks out there. You guys are here, and thank you for being here. But we're also going to have some remote speakers. We did some workshops this way already the past 2 days, which have been really interesting. And of course, we're going to have speakers in person as well. It's an interesting time. I mean, we're not going back to anything, are we? We're going through into whatever this looks like going forward, and all the shows from here. So this is a special show. It's a one of a kind. I don't think we're ever going to do anything exactly like this again. And whether you're here or you're online, I hope you'll load up the Whova app. That is where we're keeping track of everything on the show, especially the changes, because we're still got some challenges here with some speakers and with other things going on. You're going to see some changes happen, and you'll see them happen in the notes from the organizers in the Whova app. So whether you're here or you're online, if you need to go to the team session, you're having a problem getting there, don't panic. Just check the Whova app, see if we've had to reschedule or move something. It's probably there. We'll keep, for folks that are here, we'll keep the signboards up to date and figure all of that out. We also have some great sponsors this year. This special show, we've had incredible support to be able to keep doing DEVintersection, and it's been really challenging. The whole team has stayed together, and I couldn't be prouder of them. Everyone has taken a hit in the past 15 months to make this possible, and I'm insanely grateful. So I hope you give a hand to the crew, the folks in the back, the guys back here. Like, we wouldn't be here without them. And we have Learn TV here. So Microsoft is growing and evolving. It's been a challenging year for them too. They've helped us in so many different ways, and I've helped all of you as well. The pressure to move into this new world and work closely with the cloud. So the folks from Learn TV, we're going to be doing lots of Q&A online. And I hope you're watching, and I'll be participating where we can. There'll be some Q&A with Scott afterwards. One of the things that kept me sane this year was a weekly call with some friends. And I'm sure you did the same thing in one form or another. We're all tech people here. And it's surprising how different ways those kinds of calls could go. There were calls where people were taking notes because certain folks were just going on about a technology or things like that. And there were also calls where we learned who can swear like a sailor. But one of the guys that was on that call most of the time was my friend Scott Hunter, and I hope you'll put your hands together for him. Thank you.
Thank you, Richard. Yes, I put a slide in. I never put these slides in, but I put this in for fun. So I was actually born in Little Rock, Arkansas. Thank you. Graduated from Little Rock Central High. And then I moved to California to work for 2 startups, Mustang Software and Starbase. And then I joined Microsoft in 2007. And I have to pinch myself every time I think about this because I run the PM team at Microsoft for the languages, runtimes, and frameworks. And there might be some things on the list here that shock you a little bit if you know me. Yeah, obviously C#, F#, .NET, Core, ASP.NET, but there's Java and C++ there. Just kind of weird, the .NET guy, Java. But we'll talk more about that. So the joke, as I think about my job, when I joined Microsoft, I worked on C#. I probably should have worked on Java because we had this thing called Visual J++ in 1997. But we weren't good in open source back then. So, we kind of made it a custom Microsoft Java, where we didn't do some of their features and we added some of our own features. And we got sued. And we had to rip it off all the machines. Now, the interesting thing is there's something in there called dubfc, which was Windows Foundation classes. And that is the genesis of actually what is called WinForms in .NET. Basically, we took some of this tech, we wrote a new language, and we shipped it as .NET. And so instead of doing Java, I built C# tools. .NET's old. Shipped in 2002, lots of languages, all about Windows and the web, and that was it. Now, we're also a funny company. You know, as I said, the Java thing was not a good thing. And even .NET, we did some weird stuff. We did this thing. Microsoft plans to shared source .NET. And there's none of that code in actual .NET. It was actually a weird one-off thing meant for educators, but it was not good open source because, as I said, there's not a single line of code probably in that thing that's actually in the real .NET. So that was not good. But you know, we were pretty successful, and I'm going to make fun of this next slide in a second too. So this is a slide that I got from our marketing team maybe 6 years ago. 1.8 billion installs, 64K embedded systems, all this stuff. 6 million professional developers. The funny thing about that number is we didn't know how to count then. So let's go forward. In 2008, we took it a step further, and we open sourced the first parts of .NET. This was MVC. 2008 was one of the first projects that I worked on. And of course, because we're Microsoft, we can't use like any of the popular open source licenses. We make our own Microsoft MSPL. Good news is it actually was a good license. It's not a bad license. Today we do all of our stuff either with Apache or MIT, but that was actually not a bad license. It just felt weird because we had to make one. You know, you could download the source code, you could redistribute, but we didn't take contributions from the public. Richard and I talk all the time about the work it took to convince our legal team to let us actually take contributions, which took 4 more years. And so in 2012, we really open sourced the tech. We did, you know, ASP.NET Web Stack, Entity Framework, all the parts of the web stack that I worked on at the time, because I was part of the ASP.NET team, we open sourced. And you can see it was amazing on CodePlex because we couldn't do GitHub. And so we were still partially there. And you can see we actually put a proper Apache license on these things. You can distribute the source code. I won't even describe what MS OpenTech was. It was a way to do open source in a company that wasn't ready to do open source yet. But it was a path and it was a way, and we helped the rest of Microsoft be able to start their journey towards that. And then this is my favorite thing. You know, when you have a successful product, what do? You make lots of them. This list is actually embarrassing to me. .NET Framework, Compact, Embedded, Silverlight, Phone 7, 8. And so if you're me, you know, if you don't know anything about me, I'm Scott, and I work for Scott Guthrie, who's the EVP of Azure and other stuff. And so as a Scott, I have to make another one. And so in 2016, we introduced .NET Core, which was the next generation of .NET, meant to take people to the next level, and it was meant to be everything .NET Framework was not. Fully open source, cross-platform, full command line support, all those things. And that's kind of where we are today and where we're at. And this time, we really open sourced all of it with full contributions, and we're one of the highest velocity OSS projects on GitHub today. And this is just a pile of different moments in time that we open source stuff. And I gave up trying to update this anymore because we're so open now, it doesn't really matter. But that's kind of the .NET journey. And there's something else funny about this too is we shipped Java again just a few weeks ago at Build, our developer conference. We now build an OpenJDK, and we build that because we want to make sure that if you're a Java developer, you have a free runtime you can use. Oracle a couple of years ago started charging developers for using Java. And guess what? Even though we're a big .NET company, we have things like Minecraft, LinkedIn, Synapse in Azure, all built on Java. And so Java is important both to us and to our customers. And I pinch myself being able to get a chance to work on not just .NET, but Java and C++. And with that, you know, let's kind of go back to where we are now. And today we kind of live in this world. That .NET Framework world only did desktop and the web. There was no cloud, mobile, gaming, IoT, or AI. Those all came later. A lot of folks didn't even recognize some of this, like Xamarin. That's a company we bought in 2016. That's where the mobile came from. Cloud came from me. In 2010, Scott Gu pulled us out of developer division and brought us into Azure, and so we were there working on some of this stuff. If you've ever run on your phone any app that says Unity, that's a .NET game. Underappreciated how much .NET there is in gaming. With the .NET Core, we actually started working on other processors and stuff, and enabling IoT. And we took an open source library inside of Microsoft that we use for a lot of our tools for machine learning, and we contributed to .NET as well. And so now you can build all these types of apps in .NET. This is where it's fun now. Look at my number here. We have greater than 5 million .NET developers in Visual Studio family of tools. Well, what was the 6 million before? Did we lose 1 million? The reality is, back in the day, when we actually made that other number, we measured our success based on the number of downloads of our product. Today, we actually measure success based on you downloaded it, you installed it, and then you actually used it. And so the number today is more accurate, but I'm happy to say that sometime this year, we will hit that 6 million number again, but this time for real. And just to give you an idea, if you're thinking about how big are developer ecosystems, the estimate is that Java's about 10 or 11 million. And so I think the 5 to 6 million we have is amazing. Number one, love most framework on Stack Overflow 2 years in a row. The one on the right here, the top 30, you can't see the fine print here, but the Cloud Native Foundation, they monitor a bunch of open source projects and looking at how many PRs and how many issues and how many comments are accepted on those technologies. And .NET is currently the #1 project on GitHub on that measurement. And that's because a lot of the contributions to .NET are no longer from us. And that I can't imagine that. 10 times faster than Node.js. If there's any Node people in the room, I'm sorry. This is the perf stuff that we talk about. So as we started reinventing .NET, we have to ask ourselves, well, why would anybody want to use .NET? Back in the day, it was like, hey, if you want to run on Windows, you write a .NET application, but in this new world of all the devices, Linux, the cloud, why would you want to use .NET? And so as we started reinventing .NET, we said, hey, let's focus on performance. Let's make .NET the most performant we can be. And so this is showing a benchmark called the Tech and Power benchmark. There's a bunch of these that they run. This is showing plain text, which is not the most real benchmark, but we have seen all these changes we make for performance actually affect real world applications. There are plenty of services inside of Microsoft in Azure that have seen 20–25% improvements in performance and cost as they move to the newer tech that we have. On the right side, you can see gRPC, which is something we shipped a couple of years ago in .NET. It's a modern messaging framework, and you can see that as we were getting to ship .NET 5, faster than Java, faster than C++, faster than Go, just a little bit slower than Rust, but that was actually running a pre-release version of 5. These aren't our benchmarks, so we have to wait for them to run them, the open community, to see what actually happens here. And so that is our commitment, is to make .NET so fast that it runs better in the cloud for you. This is fun too. As somebody that worked on .NET Framework, I remember having customers call me and they're on like the version that's 6 years old. And they're like, Scott, hey, what happens if we actually upgrade our server with the new version? Will it break the app? So we had this problem in .NET that nobody used the new versions. They stayed on the old ones forever and forever. And so with .NET Core 3.1, when we shipped it, in the first 6 months of use, we had 3 million people switch to it, or at least use it along with one of the older versions as well. We shipped .NET 5, we had 3.6 million people start using it within the first 6 months. And so this makes me very happy as a developer. People are using our latest bits, the latest technology, the latest stuff, and not waiting 5, 6, 7, 10 years to upgrade. And that's something I would ask any of you, if you're using this tech, get on the newest versions all the time. And this kind of comes down to why .NET 5. So if you don't know, we actually rebranded .NET Core. We took the core out of it, and we went back to just saying .NET. And we did that because we want to make it very clear to our customers that this is the future. The new tech is .NET 5, .NET 6, whatever. And we give you flexible deployment. This solves that problem I said before about .NET Framework. You can have all these versions on the computer at the same time, nothing breaks. Unparalleled performance, that really is the key of our tech. And you're going to see in .NET 6, we want to fix the other part of performance, which we have, which is what we call inner loop. And I'll discuss that in a little bit more. Obviously, with that performance, better hosting costs, and less infrastructure required to run your applications. And then the last line is really more about keeping everything up to date with the latest language features and stuff like that. We're evolving C#, F#, at a faster rate than we ever have. We now ship new versions of each of those every year. And so, if you want those benefits, you need to be on the latest versions of the tech. This is something that, does anybody in the room have any .NET Framework projects? Few hands. So one of the things that people have asked us for forever is, hey, how do you actually upgrade an application faster? And so we actually have a bunch of us at Microsoft that actually take some of our internal teams that are running their services in Azure on .NET and help them move. We've helped some external customers as well. And so we took all the learnings from that. This was a tool that we built for ourselves, and it's now available today. You can grab it, and it will try to help port your application. It'll convert your project files. It'll fix your package references. It'll do some code fix-ups and stuff like that. And it'll back up your code first, obviously. But it's a great way to, if you have .NET Framework applications you want to look at moving forward, it's a great way to try to do that. Now, where are we going? .NET 6. That's the version of .NET we're going to ship this year. And it's actually something I've talked about for a long time, that we've actually finally come together into a single platform. So as we moved from saying .NET, Core 3.1 or whatever to .NET 5, we still haven't put all of it together. If you look at things like Xamarin, that's the mobile tech that we have in .NET. Well, it's a checkbox. It doesn't use the same project system as .NET Core did. It didn't use the same command line tools. We have now simplified all this down into one thing. We're going to have a single SDK that you install, and you can build all those app types I showed earlier. We're going to make the SDK something that's not huge either. You can actually we call these optional workloads. So the Xamarin tech, which will be called .NET MAUI, you can just decide to install it manually. One BCL, this is crazy. We had the .NET Framework BCL, and for BCL, that's base class libraries. That's strings and date times and networking and all that stuff. We had 3 versions of this: the .NET Framework one, the one in .NET Core, and the one in Mono, which ran the Xamarin technologies. We've consolidated all that down into a single platform now. So there's only one set of those, no matter what app type you build, it's the exact same BCL. And we have a unified tool chain as well. There's a command line tool called .NET, and it can build and run all these applications. People have asked for this for a long time. We're bringing cross-platform native UI. This means you can build a single app, and it will run on Mac, Windows, iOS, and Android. And I'm sure people are saying, well, what about Linux? Let me ship the first 4 platforms first, and we can see if Linux actually, there's enough demand for Linux. Obviously, the web is cross-platform, but I say cross-platform web UI because we're going to let you build Electron-style applications. These are desktop applications that use .NET Blazor inside of them. And so you can build a web app that can still access the local file system, local resources. It could load native DLLs if it wanted to. And so we think we're not only going to have our regular web tech, but we're making it work even tighter with the hardware. Cloud native investments, we think we're one of the best platforms for building microservices. And I'll show some cool stuff in one of the demos that talks about that. And then, of course, what we find is about every version of .NET so far, we get about 10 to 15 to 20% more performance in a lot of the common APIs. And so this will continue again in .NET 6. We get the chance to run this tech on huge workloads at Microsoft, which helps us actually work on that. So what are the big features in .NET 6? We have a bunch of features in C# that let you write less code, less typecasting, less stuff. Super exciting to see some of that stuff. We have .NET Multi-Platform App UI. Who can come up with better acronyms than that? Which we just call .NET MAUI, but that is cross-platform, Windows, Mac, Android, iOS. Single app, all those places, and you see some demos of that. Blazor, you can now build Blazor on the desktop with full access to your machine. We have minimal web APIs. If you compare like an ASP.NET application to something like Express and Node, we look more complicated. Well, that's because we built for thousands of APIs, not 5 or 10. Now we do both. We've added more support for new chips. Apple M1 support is there now. And all of our desktop frameworks, the older desktop frameworks now run on Windows ARM64 as well. And then I think the biggest one, which is too far down this list, is Hot Reload. And I'll show a video of Hot Reload, and I'll do a demo of it on my machine in a second as well, because I think it's amazing. This is a funny one too. Talk about performance. NET Framework has been this ORM we've had on .NET for a long time. I think the first version shipped in 2008. We now have a core version of that as well. But people always say, you know, ORMs are expensive, they're big, they use too much memory, they're slow. The fastest lightweight data access platform on .NET is something called Dapper. And it's by the folks over at Stack Exchange. They run it to make Stack Overflow work. In .NET 6, EF Core is as fast as Dapper. So we are now as fast as the lightest weight data access library on .NET. You can see here, 70% performance gain version to version. 31% faster query performance, and up to 43% reduced memory footprint. Speed comes by not allocating memory. And so I'm super excited to say you can have all those features in EF Core, but get the same performance you would on the most lightweight ORM that's out there, which is Dapper. In fact, the Dapper folks are off to go redo Dapper now to try to make it faster again, which is great for us to have this kind of fun back and forth with some of the folks in the open source. This is some of the stuff we're doing in C#, and I'll really highlight some of this in a second. We have something called global usings, which get rid, you can see here, global using system. You can define global usings and then not have to put those in every file in your application, less junk. Improvements to lambdas. I'll show some code in a second where you can see where if you were using lambdas before, you had to typecast a lot of times. That looks bad, so we're getting rid of that. And we're continuing to go take some of the new record work we did in .NET 5 and continue to enhance it. Where you can more easily define a class with less markup. So this is what we call minimal web APIs. And this is you can write a .NET web API with this many lines of code, 3 lines of code now. And so this is a super lightweight single file built for cloud native APIs. If you have 1,000 APIs, you probably should still use our controller model. But if you just have 5, 6 APIs, this is a great simple way to build these APIs in very little amounts of code. You can see this is actually the entire app. You might say, well, where's the main? Well, we have added a feature in .NET 5 called top-level programs, no mains required. We added a feature in .NET 6 called global usings, which got rid of all the usings. And you really can just get down to this concise code that you see here. If you want, you can easily take one of these and port it into our controller tech if you want to have a lot of APIs and manage them easily. And this is going to be available with .NET 6. And so let's do a demo of this. So some of the demos today, this is kind of weird. We were getting ready for the Build conference, which was at the end of May, and they came to us and said, hey, we want you to record all these things a month in advance. And we weren't ready. We actually weren't even ready for Build, to be honest with you. And so 3 of the demos I have today are actually videos that we produced at Build. And I just can't bring 5 laptops to the show. It's too much. So I just have videos of them, but I'll show some of the hot reload stuff at the end in real demos. So let's try this.
I am super excited to show you ASP.NET minimal APIs. We first introduced web APIs in .NET back in 2012 with the Web API project, built on top of MVC, which uses controllers, routing, attributes, conventions, dependency injection, and more to let you build enterprise class APIs on .NET. And we've carried all that technology forward to .NET 6. But we see a new trend around lightweight APIs and small microservices. and some new frameworks like Express in Node, Lumen in PHP, Fast API in Python make these super easy to build minimal APIs. We want to enable you to build the same lightweight APIs using the same ASP.NET that you know and trust, with less configuration and a path to upgrade to controller APIs if needed. To do this, we're using a bunch of new technologies. Look at this application. Using top-level programs, there is no class or main. It's just code. Using a Lambda, I can write the function in line next to my route. And if I run this, you can see that my 3-line application can return hello world to the browser. We think these new lightweight APIs are going to make it easier for you to build microservices. We think it's going to make it easier for new people to learn and build their first APIs in .NET. So I'm super excited about this. But I want to take this to the next level and show you a real API. So let me go back to Visual Studio. Here we are back in Visual Studio. And in this case, I've got 3 API projects. My minimal web API project hosted in Azure that powers the rest of the demos you'll see today. I've got my MVC web API project here as well. And I've got an Express application written in Node. Let's start off with the MVC web API. And you're going to see it's got a bunch of files, startup.cs, program.cs, and it's got its weather controller.cs. Let's dive into the weather controller. And you're going to see these APIs are based on classes that then have methods with attributes on them. Great for building lots of APIs. But if I just want to build one API, I can go look at something like the Express application here and look, it's very concise, down to 37 lines of code to build a single API. It gets right to the point. Now, if we move over to the new ASP.NET Minimal API, you're going to see it's even smaller and more concise than the Express application, 30 lines of code. And this is because we're using new features like top-level programs, global using, and Lambdas to really reduce the amount of ceremony you have to do to write a single API. This kind of technology is great for building microservices and simple APIs. Now, as I looked at this, I wanted to compare all the technologies to each other. And so what I've got down here is I've got a notepad file, and I've kind of kept a tally of how much code you have to write. So the MVC web APIs, that's really if you want to build a lot of APIs, that requires about 138 lines of code to get started. The Node Express API uses 37 lines of code. And amazingly enough, .NET minimal APIs are only 30 lines of code. And this is just showing you we're applying these new technologies to make it faster and easier for you to build great apps. So here we are back in Visual Studio. And now what I want to do is run my app locally to make sure it works. Here we go. And you can see it's pulling the weather back. And so I've got a successful API using ASP.NET minimal APIs running. Now, the next thing I want to do is switch back to Visual Studio. Here we go. And what I want to do is I want to publish this application to Azure for the rest of the demos that you see today. So I'm going to click Publish. We'll select Azure. And we'll select App Service Linux. There we go. Let me create a new one. I'm going to change my name just to Minimal Weather. I've got a hosting plan already set up for me. I will select that. Press Create here. There we go. It's creating my app service. Now I'm going to click Next, and I'm actually going to deploy using GitHub Actions using CI/CD, and click Finish. What happens now is when I commit my app, it will do a CI/CD flow to publish it. I can switch to my repo, and you can see all the steps have happened to publish my app to Azure. And now I can actually go and open my browser tab here, and this shows the minimal API that we built running in Azure. And we will use this for the rest of the demos today.
So that is minimal APIs, and some of the inspiration for that was Maria Nagaga on our team, who joined our team not as a .NET person and was like, wow, getting started in .NET is hard. Building these controller APIs is so much more complicated than the examples you see in Python and Node.js and such like that. And so we built language features to enable this, and this is all using the same ASP.NET tech. It's the same tech that powers the controller APIs. It's just a more simple, concise way to do it for people to want that. So very, very cool about that. The API we built there was a weather API. And then all of the other demos I have here use the exact weather API. So the next one we have is .NET Multi-Platform App UI, or really .NET MAUI. What this is a platform for building cross-platform native UI with .NET. Notice here that on Windows, we use WinUI. WinUI is the newest tech built in the Windows operating system, Windows 10, for building GUI applications. On the Mac, we use something called Mac Catalyst. Mac Catalyst is an API or a library on the Mac that's designed to make it easy to move an iOS app to the Mac. Apple themselves uses Mac Catalyst for many of their apps, like News and so on the Mac. And so this is the same tech Apple's using to build their apps, which makes it very easy for you to build apps that run on the Mac. And then, of course, for iOS and Android, we use the native libraries on each of those devices as well. So we have all 4 of these supported. Not only that, if you've ever used the Xamarin technology we had in the past, it actually has a project for every one of your deployments. So we'd have 4 projects here. And so we are going to condense that down. You have one project that supports all these 4 app types, one single code base, write once, run everywhere. And you can deploy to multiple devices. You just right-click on the application and tell us where you want to build a deployment for, and we'll do that for you. And this will ship in .NET 6 as well. And this is exciting tech. Not only can you do this, but one of the neat aspects of MAUI is you can also make your apps work better on the native platform. So the demo I'm about to start, we will build a MAUI app, which is kind of a common app that runs the same way on every platform, and then we will enhance it. So if you run it on Windows or a Mac, you're getting all the things you would expect. It can do native notifications. It can do right-click menus. It can do taskbars and stuff like that. So let's do a demo of this as well.
.NET 6 brings consistent experiences from all project types to .NET MAUI, including the command line. In this case, we're going to create a new MAUI app with .NET New MAUI. We're going to name it Build MAUI. Now from here, I could run, if I wanted to, .NET Restore, .NET Build, .NET Run, but I want to show you how we can build an optimized experience for building cross-platform applications with Visual Studio. So let me launch Visual Studio here. .NET MAUI targets iOS, Android, Mac, and Windows. And so what we're going to do here is take the single project here. We're going to set this to Startup Project here. And then what I want to do is I'm going to go to the debug menu here. And let me click that again, drop that down, and I'm select the framework that I want to run on. And I'm going to select Android here. And that means when I run the application, it's going to actually run the application on my Android emulator on the right here. So let's get this started. One of our goals with .NET MAUI was to give you a single project for building all your applications, so you can focus more on your application and less on the specific targets of your application. It all starts with the startup.cs file. This is very similar to what we do with ASP.NET today. This is where you configure all of the things for your application. In this case, we want Xamarin Forms compatibility. We set our default application. We're going to set our font right here. And if I'm using third-party libraries, I would configure them here as well. Maybe I'm going to use dependency injection. I want to share something across my application. I would put that here as well. And so that's kind of the way we copy that experience from ASP.NET to over here. Now we have these folders: Android, iOS, Mac Catalyst, and we have the WinUI 3 down here. And this is where you write your platform-specific code. We also have a resource folder. Inside of that, we can put your fonts, your images, your app icon, your startup screen, all in one place. And so here the application is booting up in my emulator. And what I'm going to do is I'm going to go and click the counter here. See, it's at number 5. And I'm going to show you a hot reload. I can actually change either my XAML or my C# and press save. And as soon as I do, the application updates immediately. This helps with your productivity quite a bit. Now this is a semi-simple application. Let's use a more complex example and show you how we can do platform-specific light up with .NET MAUI. So here I am in Visual Studio with my weather application. And you're going to see that as I run it here, it's a WinUI, native Windows application. But I've done a few things differently here. If you look in my configure services, I've added some new services. I've added a tray icon for putting a tray icon on Windows. I've added notifications for native notifications and a tray icon for Mac. Now, If I go and show my main page here, you can see what I've done is set up app actions. This allows me to put a context menu when you right click on the app icon, where you can put some menu items in here and make it do some other options. I've also added a tree icon too. And so what happens here, if you click on the tree icon, we'll send a notification on the platform that you're on with that data. So if I look here, I can right click. Here, my new context menu showing up right here in my applications. It's showing native UI hookup. Here's my tree icon. I can click it. And there you go. You can see as soon as I did that, a notification popped up in Windows. It's just showing you how you can do these native light ups across all the platforms. Now, I can't just show you just Windows. .NET MAUI is cross-platform. Let's go to my Mac and I'll show you a couple other options. Here you go. I've got my same UI and same code running on iOS, macOS, and Android. If I resize the macOS application, you see it resizes dynamically like you would expect. If I click the icon, you see those same menu items there that you saw before. And then if I click the icon at the very top, you'll get that notification directly on your Mac. So this is showing you how we could do this cross-platform light up, but still give you these native options with .NET MAUI, all using the same UI.
So I hope that was cool. I think, write once, run everywhere using the native platform UI on all those apps is a friggin' amazing capability, and I am super excited about it. I cannot wait to ship this in November. The next thing we thought about was Blazor. A lot of the apps we use today, whether it's Slack, whether it's VS Code, these are what we call Electron applications. They're web apps that run in a desktop shell. And of course, they need that desktop shell so they can talk to like the file system. VS Code is in file editor. It needs to be able to see your file system. But using web is great because you can use your web and share it across all these different platforms. Some people just prefer to write their UI in web. And so we love to give you that native capability again with Blazor. And so once again, you can reuse UI components across native and web. What I don't say here is you can actually put native controls in a Blazor app as well if you want. You don't have to just use web. You can do a mix of web and native controls. This is actually built on top of the thing I just demoed before, which is called .NET MAUI. It's basically .NET MAUI, but inside of .NET MAUI, you have in your XAML, you reference a Blazor project, and that will inject the Blazor project directly into your application. Something cool is the Blazor project is running in proc with the application, which means it is super fast, and it has access to the whole device. Once again, it's a native app container, which means it can have native controls as well. And this will ship in .NET 6. And you can see right now, we're primarily targeting Windows and Mac for this, but it will work on iOS and Android. I just don't know if we're going to put supported next to those in this time frame. But the tech is the same tech, so it should actually work across all those. There might be a few limitations on the mobile devices if you want to build a web-based app that runs in all those places. And then here is a demo of Blazor. And we're going to start off with, before I start the demo, we'll start off with just a plain Blazor application, a web app. And then we'll take that Blazor application and wrap it into a native app. And then we'll give it those same native hookups that we gave the real .NET MAUI app as well, because it can take advantage of the system platform.
Blazor makes it easy to build rich, modern web UI. Here's our weather app, implemented as a web app using just HTML, CSS, and .NET. The web app has a nice responsive layout, so it looks good on mobile devices as well as desktop screens. We can see the current weather and local weather forecasts. We can also check out the weather from other locations. Here's the weather in South Korea. Here we can also change the settings of the app to switch from imperial units to metric units, and it automatically gets applied to the entire application. Now, all of the client-side interactivity in this app is implemented using reusable Blazor components that work in any modern web browser using just the open web. The app calls our Azure-hosted minimal weather API to get all of its weather data. By pairing Blazor with an ASP.NET Core server, you can build full-stack web apps with just .NET. Our weather app can still use some improvements. The list of weather stations on the right-hand side looks a bit plain. In .NET 6, we can quickly make changes to our ASP.NET Core and Blazor apps using .NET Hot Reload. Here's the component that displays each weather station. As you can see right now, it's got some simple markup. Let's update the styles for this stacked box class. Save that. It gets automatically applied. It looks nice now. Let's also add some markup here in order to better lay out the text and maybe add an icon. Save that. With .NET Hot Reload, our changes get applied to the running app without losing any app state. Blazor makes building web apps with .NET fast and fun, but sometimes you need more than what the web platform offers. By combining Blazor with .NET MAUI, you can reuse your existing web UI logic and web development skills to build cross-platform native apps that can take advantage of the underlying platform. .NET MAUI comes with a built-in Blazor web view control that you can use to add existing Blazor components to any .NET MAUI app. This means we can take our Blazor components from our weather app and embed them into the .NET MAUI app without having to change anything. Here is our weather app running as a native desktop app on Windows. It looks the same and has exactly the same functionality using the same Blazor.NET code. Blazor components hosted in .NET MAUI run directly in the .NET process. This means they run fast and have full access to the native capabilities of the device through the .NET platform. For example, we can reuse the same system tray integration that you saw previously and trigger native platform notifications. Because this Blazor app is running inside a .NET MAUI app, it can run on other platforms too. Let's switch over to my Mac to see how Blazor desktop app can run cross-platform. All right, here is our Blazor weather app running as a native Mac app. As you can see, it's got the same look and feel. It's got the same functionality. If we check out the weather in South Korea, we can do that. There it is, and it looks and feels the same because it's the same code that we ran in the Windows app and also on the web. The app also has native integration, so it can show the little .NET bot up in the menu. We can click him and trigger a native notification. By building our app as a Blazor hybrid app with .NET MAUI, we get the best of .NET, the best of the web, and the best of the native platform.
So that is .NET MAUI with Blazor. Something else that's really cool about that is these apps, which we've not even worked on actually optimizing yet, are very small in memory footprint. So we all know that some of the Electron apps, including Teams that I'm running right now, can end up using a lot of memory. The native version of the weather app was using about 80 megs of RAM. The Blazor version of the same app was using 95 megs of RAM. So under 100 megs of RAM for a real functional application with real UI with web. And so we think if you're a .NET developer, whether you want to use native UI or you want to use web, we have you covered with both of those techs. You can do more with .NET. Now, let me define a term. There's a term that we use inside of Microsoft, and none of you would ever use this term. I never heard of it until I worked at Microsoft. And we have a term called inner loop. And the inner loop is the loop that we as developers do. You write some code, you run your application, you look at it and go, yuck. You stop the app, you change the code again, and you reload and you rerun the application. That loop of making a change, seeing it reflected in your application, and then doing it again and again, we call that inner loop. And so one of our biggest goals in .NET 6 is to work on the inner loop. You've seen on the benchmarks that .NET is amazingly fast as a runtime, but our inner loop performance is not good. If you compare us to Node.js or a React app or a Flutter app, they just have a much better developer feel. In some ways, because some of that tech's not compiled tech, it's actually interpreted, and so they don't have to restart apps and do stuff like that. But this is something we want to fix in .NET, and we've already made more progress than I ever thought we would have in .NET 6, and we'll continue with .NET 7. You can see just generally across the board, Just a clean build of a Blazor server is less than half of what it was in .NET 5. Incremental builds are much faster. And then for MVC applications, basically you can see here that even before we even start talking about doing what we call hot reload, we've improved this amazingly across all these things. So lots of build time improvements, and we actually had to stop doing these. We had more. We can make each of those purple bars a little smaller, but we ran out of time. Even though we're 6 months from shipping, we needed people to go work on some other stuff. But in .NET 7, we'll take another hit of this and remove more of this. Hot reload. And if you don't know what hot reload means you just change your code and the app updates without doing a stop, recompile, run. And we've had parts of this in some tech for a long time. We've had edit and continue, which worked for WinForms and WPF projects and WebForms projects. But we want to make this tech work everywhere, whether you're building a console app, a Windows app, ASP.NET app, a MAUI app. We want this to work everywhere across all the project types. And this is a big thing. We don't want to restart your process. So we want the state to maintain, so your app stays where it was before. You saw that in the demo of the Blazor desktop stuff. And there will be cases where we do have to restart the app, but we've actually figured out how to actually restart the app without killing the process, because processes are expensive in Windows. And so we can do that too. And then here's another thing too, is if you've ever used edit and continue, it requires you to use the debugger. I never start my .NET apps with a debugger. I always start with Control F5 because it's a faster experience. And so we're going to have a new experience where you can actually start this, get the hot reload, and then if you decide halfway through your session to add the debugger, you can. And this will be an evolution of edit continue. And I'll do a demo of this real quick. All of the stuff I'm showing that I said was undimmable should be dimmable maybe in a week from now on bits that we're going to release to you folks. But here's hot reload.
For this demo, I have two apps to show you. First, let's start with the WPF app running on the right-hand side. This is a .NET 6 app called Voids, a game of life simulator, and you can see many shapes moving around. With .NET Hot Reload, we can now change the game logic while the app is running. To do that, we're going to press this brand new button. Now let's go ahead and make a change to the app and see how it works. I didn't build the app, so I'm not sure what changes to make, but let's go ahead and change speed limit. That seemed like it's going to do something. So I'm going to go ahead and change that. How about we add 10 to it? Now I'm going to apply the change. And as you can see, the behavior of the game is changing right away. I'm going to undo that. I'm going to make a different change. I'm going to make a change to the percentage to move towards home. Not quite sure what that's going to do. Let me just add 0.1 to that. And again, I'm going to apply the changes. And now you see a dramatic change in the app without having to restart it. While it's fun to show you an app like this, I now want to go back to our weather app and show you some edits that should feel like real world situations. Let's switch over to our weather app. Here's the weather app you've seen in the other demos. As you know, this is a .NET MAUI desktop application, and here too we can apply code changes while the app is running. So first I'm going to look at the wind indicator. I expected some simulation code to have been added to make the indicator move. Let's go ahead and see what happened. Let me go look at the code and find there's a to-do here. Instead of stopping the application, I'm just going to go ahead and add the code that I would have expected to be here. I'm going to add a get direction, which gives me some random directions. I'm going to change it so it applies the direction icon, and I'm going to apply those changes. The indicator starts to move. For favorites, I'm going to go ahead and click that button. And it seems like something is missing here as well. So let's go look at the view model. Well, I have some properties here, but it seems like I have no logic to load the data. Let's make a change that's needed. Now I could have typed this, but just to save us some time, I'm going to paste the code in. It should have been here. And you can see we have a constructor, an async method, private method. All of this can be applied to the running app by hitting the apply code changes. Switching back, I can go ahead and switch to the home screen, switch back to favorites, and now I see the data. But I see one last bug. It's only loading Redmond. Let's go take a look. Yes, would be easy to miss. It should be an I instead of 0. I'm going to apply those code changes and navigate back and forth. There we go. And now we get all the data we expect. Now with this app, it easily could take 15 to 20 seconds to restart the application. And it's a small demo app. But with hot reload, we were able to make all these changes without having to restart the app a single time. Imagine how much time it will save you.
Cool. And that's hot reload in .NET 6. I want to do one thing here. Sometimes I think like the videos don't have enough of the flavor of this. I want to show this in person. So this is, I'm not even going to show it in Visual Studio. I'm going to show it from command line. So I've got a Blazor .NET 5 application here, which I can run. Actually, let's do this. And it should launch the browser, I think. I don't know what state of. Huh. Well, I can work around that. Normally it would actually launch that for me, but let's just do this. We can control click, bring it up. Here's a Blazor app, and I can come over here and put this over here, put this over here, and we can make changes in this. This is a .NET 5 application, so let's go to the counter page, and we can say the dev intersections. And I don't think it's going to actually refresh for me because it's not doing the refresh model. Sometimes when you have too many beta bits. I know the 6.0 one will work, and I'll just go and show the 6.0 thing here. So let's just cancel that out. I know 6 will do what I want. So the 6.0 one's launching. Notice it says hot reload enabled. Launched at the browser. And if I was smart, I would have actually here's the code. So I've got my Blazor app, and I've got a VS Code running. And let's take a look and see what the perf is to update this application. So we'll go back to the counter page. And let's say in .NET 6, give it a second here. Now what I'm going to do is I'm going to add a couple exclamation marks here, and I'm going to press save. Now, take those back away, press save now. That is instantaneous. Let's click the counter. Okay, I went to 10. Now let's go change the code. to go by 2. I'll press save. And now we reset the app. The app actually blinks a little bit. It's reset. And it kept the state. Notice it still says 10. And it's still there. If I click the button, it now goes up by 2. So basically, you can make markup changes. You can make code changes, even from the command line. And we can update these things instantaneously. In Visual Studio, it's even better. Because in Visual Studio, we're actually running code to actually run IntelliSense. We're compiling your code as you type. So when you press that apply button, we take the code we've already compiled in memory and just inject it directly into the running application. And so it is sub 100 milliseconds. And to me, this is one of the biggest missing pieces of .NET. We've, as I said before, we've had great runtime performance. We've not had the best inner loop performance. And you're going to see us take this as serious as we've taken any of the runtime performance as we move forward. And so I'm very happy with that. And with that, let's go back to slides. Preview 4 is available today with MAUI support in Visual Studio. You can build the Blazor desktop applications. There's some templates with minimal APIs. And so I would ask people to go to .NET/get.NET 6 and grab that preview. We plan to ship, I should talk about this too. We have this ML.NET library that does machine learning. It's actually a library used by Office. And if your machine supports Windows Hello, that's where you can log into your machine by your camera. That's all running this tech. And we've added support for more architectures to it as well. We've added ARM64 and M1. This means you can now run ML.NET inside of Xamarin projects on iOS and Android. We have this cool tech that's in the picture here called Model Builder that writes a lot of the code for you and helps you train your models and stuff like that. And before it was kind of, every time you went through it, you had to restart the whole thing. And now it's actually a reentrant. You can go back and retrain or change some parameters and do those types of things to make your tech work. And we have a feature called AutoML there as well, which will pick algorithms and stuff for you automatically. So there's a bunch of improvements in ML.NET. And then I really have to say is we're going to ship everything I showed you on November the 9th. And we have our own virtual conference on November 9th as well called .NET Conf. It's our 3-day event that's both, it's about half Microsoft and half community, where we will show and talk about all the new stuff in .NET 6 that will ship that week. So that's .NET Conf. And so, thank you so much for coming out. I want to say something as Richard said when he kicked off, this is the first in-person event I've been to in over 15 months, I think. I think January of 2020 or something was probably the last one of these. And so I want to thank everybody for hanging in, coming out. Even Microsoft, there's a couple of us, there's Scott, Kate, and myself from Microsoft. We have no travel budget because with COVID, the company was like, well, we don't need anybody to go anywhere because there's COVID. And so it was even hard to get money to come out here and see you folks. But I really am happy to be here. I'm glad we have an in-person event. Thank you for supporting the show. And with that, I will also say there is a new in-person show that will be this December, probably on a much bigger scale than this because we will be 6 months more into vaccinations and stuff like that. So thank you so much. I have a session later today where I'll go deeper dive on a bunch of the .NET stuff. If you want to come and attend it, I think it's at noon. But thank you so much for coming. Hope you enjoyed the content and see you next time.
And so what we'd like to do is, if you want to stay, we're going to do a live Q&A with a mix between the people that are online, and Scott's going to stay on stage for the next 30 minutes. So if you have questions, I'll give you a microphone. Just raise your hand and catch my attention. But Scott, there was a lot of questions online about hot reload. So I wonder if you could talk specifically, 2 or 3 people asked about what's the difference with that little button where you said, have to click this to get hot reload, and then when you showed the version 6, it was just save to hot reload.
Yeah, so a couple things. The button, I'm not even sure the button actually stays in the product. The button was something we did in the build time frame as a way to test the technology. We don't know if most of the other techs work on file save. The cool thing about the button is it doesn't even require you to save the file. You can press the button without saving your change to the disk at all.
So the button is almost like a live watch. It's not. It
It's a
requires
live
no
watch,
save.
which means you don't have to undo your file and have, get complaint that you've changed the file or anything like that. And so it's whether we keep it is going to be based on the feedback we get from customers. If customers say that we should leave it, we might leave it. What I was showing you from command line was just saving the file makes the change. And that's because from command line, all that we have is, we're watching the files on disk.
And while you're on hot reload, where is that going to work in .NET? We saw it in Blazor.
The plan is to make it work in everything. So you actually saw it in more than just Blazor. Remember, the hot reload demo was that was a WPF demo with all the shapes flying around. That was a Blazor demo. I mean, a WPF demo. I made it work in WinForms, WPF, console, ASP.NET, Blazor, MAUI. It works everywhere.
All right. And Craig, live in the audience, has a question.
Hey, did you say that .NET 6 won't have support for Linux, or is that just .NET MAUI?
The desktop tech. So
Okay.
We already support Linux. We're not taking any Linux support out. We have a huge amount of Linux usage with the tech today. There's no mean to take that out. What we said is, people always ask whenever we show .NET MAUI, they ask me, hey, are you going to do desktop support for Linux? And then I ask, well, if I did it, would you actually use it? And they go, oh, I don't know. So there seems to be lots of interest, but I've only had one. I was talking to Richard Campbell last night about this. I've only had one customer that actually had a valid use for it. And so we will keep looking at it. I will say that there's some of the engineers in the team have a prototype of .NET MAUI running on Linux today. I just don't know. We might release that as an experiment for people to try.
All right. So you have an interesting perspective because you see all of this stuff get built. I'm wondering if you could tell us what your favorite part of .NET 6 is, not just a feature, but how and why it's there.
So my favorite part of .NET 6 will be hot reload. That was something that we had identified at the end of .NET 5. So, we're always looking to see where we are competition-wise. When you see things like the minimal API stuff, that's because we had some people saying, hey, I tried .NET and it seems really complicated compared to Node.js Express. And I'm like, okay, well, maybe that's a problem, and we should go look at that. And Marita Gaga on my team, researched a bunch of stuff there. But we had identified that the biggest challenge we had was, we got feedback from Blazor customers, especially saying the delay of making a change in Blazor and seeing it actually reflect in the browser was just too long. And then we went and looked and tried building some React apps. We built some Flutter apps. We built some Node apps and solved that perf problem there. And so the thing is, we've known this has been a problem for a while. And we had some amazing engineers go, oh yeah, it's not a big deal. I'm like, well, it's not a big deal, but it's 5 years later and it's still not a big deal. The crazy thing was, once we applied some of the really crazy engineers at Microsoft, Stephen Tobe, David Fowler, and whoever else I'm forgetting to mention, seeing the performance improvements start happening so fast. When we get serious about working on something, it's amazing what our team can actually pull off. And it was Stephen Tobe that actually showed me a WinForm app not long after we had really started the deep dive on this. But to me, that's probably my favorite part, Scott, is just the improvement. You saw how fast that Blazor app updated. That's just crazy.
Yeah, it's real-time updates. And you actually showed this too, but to clarify some people online, that's not just markup that's updating. You can actually recompile and push bits, like an event handler or any of your code is being patched, right, rather than being reloaded.
Right. And in both the demo I did at the very end from command line, I changed the C#. As much as I changed the actual markup. In the demo where we were doing the weather app, we actually added the method to make the wind indicator move to the application. And so what we learned from this is we had tech like edit and continue, which did this with the debugger running before, we just let that tech rot a little bit. And by rot, what I mean is, as we added new features to C#, edit and continue didn't understand them. So we've gone and added support for lambdas and a bunch of other stuff to this tech, and we will continue to add more. And so we're looking to see, what I would tell people, grab the previews, try the hot reload, and when it makes your app restart, because it's something we don't support, tell me and tell us and let us know with feedback, and we'll go try to address the top areas so you can make more and more changes to your app without having to restart it.
Okay, thank you. So we've got a couple more questions on Learn TV, but also live in the audience. While Scott answers the next question, let me know, I can bring you the mic. Can you talk more about ahead of time compilation? It seems as if there are some pros and cons there. And when I see ahead of time compilation makes things faster, I then start to think, should I always do that? Or what are the pros and cons of ahead of time compilation? And maybe even a little bit deeper description of what ahead of time compilation is.
Yeah, so when you're running .NET or you're running Java, these are JITted languages, and that stands for just in time. JIT stands for just in time. And so what happens is when your .NET application is running and the code executes the first time, our compiler actually creates something called IL. And then as the app runs, we convert the IL to native machine code for whatever platform you're running your application on. So there's a cost there. We're actually jitting as the app runs, so we have to boot the jitter up and make that actually happen. There's another thing you can do called AOT, which is ahead of time compile, which gets rid of the JIT. Because you don't have to JIT, because you've actually converted everything to machine language to start with. There's other challenges that brings. If you AOT, well, then you need a version for every platform because the application is coded to a particular architecture. So the most common place where you can AOT tech today in .NET is both in Xamarin, and which will continue into .NET MAUI. And that's because platforms like iOS don't support jitting on the platform. So we have to be AOT to run on an iOS device. Now, Blazor is the newest entry in .NET that is taking advantage of AOT. So you can run Blazor two ways, Blazor server, where when you act in the app, we send the request back to the server, it re-renders the page, and we send the delta back. Or you can run WebAssembly, which lets you have completely standalone web applications that can run totally disconnected from the internet because they are ahead of time compile. So in .NET 6, we're adding AOT support to Blazor. And so the way Blazor works today is we actually run an interpreter in WebAssembly, which means your C# performance is way slower than it would be if you ran it in like a desktop application, because we're using an interpreter, not a jitter. So we are going to offer the option in a Blazor app to AOT it in .NET 6, which means you can pre-compile the entire application into native WebAssembly, which will give you much faster startup times and stuff like that. The negative is going to be, it's going to make your app bigger, because native code is bigger than IL or that we use in .NET today. In the future, I would hope in .NET 7, we're going to let you decide which parts of your app we AOT, so we don't make you pay a huge cost. It's like, the only thing that really matters for the AOT stuff is the areas that you're doing really tight loops or doing math or stuff like that. So you could easily not AOT 80% of the app and only AOT 10 or 20%. We don't give you that dial in .NET 6, but we will in .NET 7.
That's great. So yeah, I'm still trying to wrap my head around all of the options. It feels like then today, the best option is, for the most case, just let the jitter run for me. You said something that I hadn't thought about. If I compile ahead of time, I actually have to ship to the native device. But if I ship and let the JIT control, then that just sort of happens for me. I get that for free, and that's right. the pros and cons.
You can build one thing that
right.
can run everywhere, one DLL that would actually work everywhere. I will back to the question. There is something you can do today. Here's an ASP.NET Core app. And let's make it just, sure, it doesn't really matter what kind of app I run today. There's another option today. For anything other than a Blazor app, a Blazor WASM app, or a Xamarin app, there's actually another option. These options, unfortunately, are so hidden that most people will never find them. on my list of things to fix. But if I go do a publish, and what I'll do is I'll say I want to publish to a folder. Sure. That creates a publish profile. And in my publish profile, there's some settings. And if you look here, I've got a couple of publish options that people might not be aware of. We might make them available here. We don't.
But I can see in a scenario that you may want to have different settings on your desktop if you're developing and you want that inner loop to go fast versus when you publish and you actually deploy something, you can do something different at deployment time.
Well, we have another feature, and I thought it was in the publish settings, and it's not. You have to just edit the project file manually to do it, which is making me unhappy. We support something called ReadyToRun as well. And ReadyToRun is a feature where we will precompile more of your application for you. It's kind of a mix between, it's not full AOT and it's not full JIT. It's in the middle somewhere. So you can build an application, a .NET application, and turn ReadyToRun on. It'll make your app a little bigger, but it will start faster and it will execute the beginnings faster because it's actually already precompiled for you a little bit. So it's just Google .NET ReadyToRun. And you can see how to turn that on.
And that's probably out of project settings, so that's great for something like a class library. But yeah, I'm sure there's, again, pros and cons to that as well.
As I said, here you go. There's a whole article on it here.
Okay. Yeah, docs.microsoft.com, search ReadyToRun.
And you can see that I can just set publish ready to true, ready to run to true. This will make your app a little bigger on disk, but it'll start faster. So we have lots of options.
All right, switching subjects just a little bit to Unity. Andrew has a question.
Yeah, so we use Unity to build a lot of mobile apps to take advantage of some of the AR capabilities and 3D capabilities. And I don't know how much you know about Unity or are involved with it, but as you mentioned, it does use C# and .NET, but not always the latest version, and it's a little bit different in how it operates.
Yes.
Compared to like a pure, .NET core project, for example. Do you have much insight as to how much you guys work with Unity or how much that's gonna maybe become more streamlined in the future and Unity become more .NET compliant, for lack of a better word?
Right. So Unity, that's a great question. We do talk to the Unity folks quite a bit. And they've actually, if you look at their blog, they did a prototype maybe a year or so ago where they actually got Unity running on core. The reality is they have a big, huge platform and they don't make huge platform changes on a regular basis for obvious reasons. But we are working on getting them to what I would call one VCL. That is the same base class libraries across everything that we're doing on our side. And there's an eventual path to .NET 6 or whatever version it'll be when they're ready. So it's coming, but I think you're looking at still maybe 1 to 1.5 years out, and that's just I'm guessing a little bit, but they move slow, and they move slow for a good reason. They have lots of games and stuff on their platform, and it will obviously be a semi-breaking change for them when they make the change. But yes, I look forward to the day that we actually you can take advantage of all the newest C# features. That's the biggest thing you're missing right now is some of the new goodies that we put in C#, and you're missing some of the improvements we put in the BCL that they don't have. But we are working with them, and there is a plan.
Sorry, did you have a follow-up, Andrew?
No, that was it.
Oh, great. Thanks, Scott. Okay, so the next thing we have is talking back to MAUI, deploying to Mac or building something for Mac, but on Windows. If you have code that's write once, run anywhere, do you have to have a Mac to test it?
Oh, definitely. You need to test on whatever the native platform is. So one of the things we have in Visual Studio today, if you don't even know this, you can build iOS apps in Visual Studio today without having a Mac. You still need a Mac to publish, but we have a feature where you can basically take any iOS device, plug it into the side of your laptop. You have to have a free Apple developer account. You have to have iTunes installed on the computer. But if you meet those requirements, we can actually let you run on the device directly on your Windows app, Windows PC, without having a Mac there for that. To put the app in the actual store, you have to go through a Mac to do that. So on a Windows PC, you can try the Android stuff out. You can try the iOS stuff out. The Mac one will be a little more challenging because you'll have to copy it to a Mac to actually see what it looks like on the Mac. Maybe we do something there. It just depends on what people do with the tech. We don't know yet, but
I want to do this.
Sorry, I was looking at a few things. There's a ton of interest around hot reload, and so this will be our last question. Is there any advice that we can do ahead of time to write code so that it's better available for hot reload, or everything is available? So we talked about the migration assistant. If I have .NET 3.1 and I bring that up to 6, is there any heads up or something that people should use to make changes to the code now so that it will be easier for hot reload, or everything just works?
the hope is that everything will work. The big challenge on hot reload is the things that don't work. And if you think about it, there's a main in your program. And like a great example is this minimal web API that I showed.
Right.
I'll bring the slide up. Let's go back to slides. Okay. This app, if you change hello world to say hello DEVintersections, well, hot reload can't help because this app is already run that entire code once and we're done. And so this is a case where we'll have to restart the process. Well, actually, I shouldn't say it. Restart the application, and we're already prototyping how to restart this application without restarting the process. So we can't keep your state, but we can still make the change happen much faster. So let's say you change something, and this will make sense to you, Scott. If we change something in startup.cs, well, that code's already run.
Right.
It's not going to run again until you restart the application. So we need a mechanism to let you restart in cases where you already run startup code that will never execute again anyways. And those are the primary things to think about. Like in any of the UI stuff I showed, it all worked because there was loops happening.
Right.
And I was able to change code inside the loop. But if there's code that's been executed one time and it'll never execute again, you'll have to restart the application. So I can't think of anything to prepare for.
That's actually helpful. I mean, not everything is reloadable because in this case, it's already been JITted. Like that hello world is a hard-coded string that the compiler already knows about.
It's already run. We're
Right.
at app.run.
Yeah.
It's not going to jump back up and try to rerun line 5 again.
Right.
And so you just have to think about it in your head. Is this code that's going to run again? The UI apps especially, this makes total sense because you hit the page again and again and
Right.
again, and each time you hit the page, we run the page again. And so as long as you have code that executes, that's the code that you can change.
All right. Well, thank you, Scott Hunter, for joining us on Learn TV, and everyone in the audience, thank you for coming out to participate. We certainly appreciate your time. And for everyone online, stick around. Please enjoy the rest of the conference. Thanks.
friends? Yeah? We doing all right? How you doing out there, friends on Teams? We've got a bunch of folks watching there, and I understand there might be some folks watching on Learn TV. My apologies. There was a little bit of confusion with getting a camera set up. I'll have that set up for my next session. Good morning, good afternoon, good evening. My name is Jeff Fritz. I'm a principal program manager at Microsoft. I work on the .NET and Visual Studio teams with a focus on community, and particularly with a focus on Blazor and live events. So training and being involved in these types of things is right up my alley. So I want to talk to you today about the next generation of user interface, what we're really pushing, what we're promoting, what we're saying is going to be, and what we believe is the next hotness, where you want to be building applications, and that's with this framework called Blazor. So let's talk a little bit about what Blazor is, why we think it's really the next generation stuff for you to use, and what you can do with it today. Now, this is a very beginner session. This is going to be very much talking about how the technology works, how you can get in and get started with it, showing a couple of examples, but very much getting in at the beginner level. I have a session a little bit later today where we're going to get in, we'll be a little bit more advanced, talk about building components and building some more complicated things to work with Blazor. So let's talk about, let's get through some of the slides, thank some of our sponsors and exhibitors. Blazor's built on this thing, it was initially built on this thing called WebAssembly. Well, WebAssembly, that sounds like a throwback. That sounds like something right out of the 70s meets 2021. What is WebAssembly? So according to webassembly.org, abbreviated WASM, WebAssembly is a binary instruction format for stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. That's a lot. But let's boil that down. What does that mean for us as developers? It means you can program with your favorite programming language, and if it can compile to a different runtime target, we can deploy and run in the browser. Let me say that again. You can build with your favorite programming language and compile it to run in the browser. The browser typically, right, is where we have JavaScript running. If you want to write code that runs in the browser, back in the day you wrote Java applets, right? You wrote an ActiveX control back in 1998, right? You wrote Flash components. I see a couple folks smiling going, yeah, we did that. You might have written Adobe Flash at one point, Shockwave, right? We had all these different formats, but they were very proprietary. They were things that one vendor would support, and there were extensions onto HTML so you could embed and drop those components into your web pages. WebAssembly is not an extension. WebAssembly is part of the HTML5 standard. So whatever phone you're using, whatever device you're using, if it's working with a modern browser, it supports WebAssembly. So what's that mean? What can we do with this? Well, WebAssembly, since it's binary code running in the browser, it's not interpreted. So it makes it efficient and fast, okay? Because we're loading binary data, binary applications in the browser for it to execute. And we've learned from the running of the JavaScript runtime in the browser, and now WebAssembly, WASM, runs in the same memory-safe sandboxed environment. So anybody who goes and deploys an application that runs in the browser on the client, they don't have access to things like the file system, right? They don't directly have access to things like different sensors on the device. They only have the ability to edit what's inside the browser frame. And that didn't resize properly. So it integrates with the features you already know. And it's part of the open web platform. These are things that we know how to build and work with as web developers. So we can continue to push and develop web applications, we can integrate with JavaScript, and we can continue to innovate with WebAssembly. So I mentioned everybody's browser has this. Do you remember Spectre and Meltdown? It's been 4 years since this thing happened, but back in 2017, there was this vulnerability that was discovered in basically every processor, right? I'm not going to get into how that vulnerability worked, but what it did do was it forced every operating system vendor and every browser vendor to release new versions and push updates to everybody's phone and everybody's machine. Every operating system was updated. But what that delivered was updates to the browser to support JavaScript patching, and it also came with WebAssembly. So even our relatives who don't keep up with patching their machines, right? Here in the States, whenever I go visit my family on Thanksgiving weekend, I end up being that family IT guy and applying all the Windows updates, applying all the updates to their phones, and making sure that everybody's secure. I don't want my mother-in-law to inadvertently get her machine attacked, right, by somebody who's exploiting an unpatched version of the operating system. So we do these things, everybody's patched up. Well, now folks like my mother-in-law and my non-technical family members, like my mother-in-law, they've all got the ability to run WebAssembly. Okay, that's something. That means I don't need to go and install clients and patches and things to get this working. But why not use JavaScript? Why use WebAssembly instead of JavaScript? I've already got so much written with JavaScript. Well, the folks from the WebAssembly group, they say WebAssembly can be natively decoded much faster than JavaScript, can be parsed with experiments showing a 20 times performance improvement. Okay, now we're talking. Now we're getting somewhere. All right. WebAssembly can be targeted by many different programming languages and frameworks. So many of us in this room, we're .NET developers, we're C# developers. I can build with C# and it works in the browser. But there's all kinds of other languages that are enabled to work with WebAssembly also, like all of these. So now the browser is not just a JavaScript playground. There's some crazy languages up here. Poetry, Prolog, Rust, Zig. I've never heard of Zig, but it was on the list from the awesome WebAssembly languages website, and I dropped it in here. Kotlin, assembly script. What's assembly script? But that works. You can do this, okay? So let's take a look at some demos from the awesome WebAssembly website of just how WebAssembly works in the browser and what this performance bump means. And then we'll take that over and start looking at how we can use that with Blazor. There was a notes page to go with this. Because my notes, no matter. I'm going to go over here. So this is the awesome Blazor website that has all kinds of Blazor demos. But what I want to show you is over here. Nope, where'd that browser go? Are you kidding? This is Doom running in the browser. I'm going to show that one in just a second. But there's also Diablo working in the browser. And I actually had this running a few minutes ago. But this is Diablo running, built with Blazor, okay? Recompiled and running in the browser. So back in 1997, the folks at Blizzard North built this game, Diablo. And it's been recompiled, runs on .NET, live in the browser. And I can log in. Of course, I'm going to log in as C# Fritz because he's quite a mighty hero. And I can get back to running around in Tristram. And on this machine, it renders and I can play, I can interact with the game, and it looks and feels like it did back when I was in college in '97. So we've got a little bit of power now in the browser we can work with. I'll go over to that other demo that I brought up, because whenever there's a sufficiently sophisticated new technology that folks want to brag about, hey, look what we can do on mobile device X, on tiny screen Y, they run Doom. We can run Doom. And it will load up and run in the browser. Okay? So this isn't just something simple that we're going to use to manipulate forms and data. But the power of these very high-end games running and animating live in our browsers really tells you something that we can do impressive things with this. This is all running locally on this machine. I'm not going back to a server and downloading video content and presenting it. It's downloaded the DLLs, the binaries, the map packs, and it's running it in the browser. So we've got this step that we've taken where, and I'm not going to get into actually playing the game here. The intro takes a little bit too long. But we've stepped into a place where deploying and building applications that are going to run on our phones, our tablets, and our workstations, now the promise of, yeah, do it with the web, now we can do a whole lot more live in the browser. So this is the awesome Blazor list being maintained out on GitHub from Adrian Torres. I'll have a link to this at the end of the presentation. So, okay, there's a lot we can do there as we look to move forward with our applications. So how does Blazor work? What exactly does Blazor do for us in the browser? So our typical browser is there on the left side, and our servers usually run on some sort of data center, or they're hosted in a nice blue, lovely shade of blue cloud, and you get and fetch data back and forth from it. And hopefully you're running ASP.NET Core because it's the fastest commercial web framework available in your fluffy blue cloud, and you're sending data back and forth to the browser. And the way that most folks who want to build an interactive local application in the browser, the way they do that is they'll use one of these, Angular Reactor View, on top of the JavaScript runtime in the browser, and they're fetching data from services, microservices that are running out in their data center. So as a C# developer, I want to be able to move forward and use Blazor. I'm going to replace all those JavaScript frameworks that are running and replacing the contents inside my browser. I'm going to replace it with Blazor so that instead I'll deliver all my DLLs instead of all JavaScript libraries. I'll deliver DLLs into the browser. They'll load up and render content, and I'll fetch data as needed from the server. It's quite magical, you might say. So Blazor, we can build client-side web UI with .NET instead of JavaScript. It compiles down and runs in the browser. We can write reusable web UI components with C# and Razor. We know how to do that. We've been doing MVC for 13 years. So Razor's pretty cool. I'm very familiar with that. Share .NET code then between client and the server. This was that key feature that so many of our friends that went to JavaScript, went to Node, loved, because they could take their logic they had in the browser, move it to the server, and it was the same language both on the front end and in their back end services. We can call into JavaScript libraries from Blazor as needed. We can reach in, we can execute those. We have to request and put a little bit of configuration in there, and it will work. Now, Blazor works on either the client or the server. So when it runs in the browser, we have Razor components that run on top of a .NET framework that compiled down to WebAssembly. And this is just like it runs on Windows, Mac, or Linux. You have your .NET application that you built with C# and whatnot, right? WinForms, WPF. It compiles down, runs on a .NET framework that runs on a runtime built for that operating system. Well, in Blazor, it interacts with the DOM. With Blazor Server, same type thing. We have our Razor components in .NET. Well, they run on an ASP.NET Core server out in the cloud or on a hosted service in your data center, and they send data back and forth to the browser using SignalR. SignalR is our live communication technology that provides live updates using WebSockets or a series of other technologies that it will step down through. Okay. So we have some options. We have two different choices of how we want to build our application. Now, Blazor WebAssembly was released with .NET Core 3.1, and it's available going forward. So it is also available in .NET 5, and it's being updated for .NET 6. Blazor Server was first released with .NET Core 3.0. It's part of all the versions since, so it is part of a long-term support instance with .NET Core 3.1. All right. Now, why would you choose one over the other? I changed my font back. That's really hard to see for the folks here in the room. Blazor WebAssembly is great for offline support or progressive web apps. Zero latency in the user interface because all the code is local in the browser and working, which also means you can host it as a static website. And I have a session tomorrow morning talking about Azure and static websites with Blazor. I hope you come back for that one. Blazor Server, though, because we're rendering all of our components on the server, makes it really good for thin clients, right? If you're interacting somewhere where they don't have very good network connection and you don't want to have to send a lot of content down into the browser, you can use a very thin client, run with the full ASP.NET runtime on the server, and all of your code is on the server as well, right? Haven't you ever wondered with JavaScript applications why people don't go through and just edit the JavaScript code live in their browser? Well, you're pushing all of your DLLs down into the browser with WebAssembly. With Blazor Server, all of your DLLs, all of your intellectual property stays in the data center. It stays on the cloud somewhere that you have full control over and nobody gets access to those binaries. Okay. So let's get started with Blazor. Let's do some of the basic getting started things. Let's actually run an application and go through and take a look at this a little bit. So you can download and run the .NET 5 SDK for Windows, Mac, or Linux. Once you have that installed, and there's great instructions from Blazor.net or from get.net, that website, get.dot.net, and you can run .NET New, Blazor, WASM, and just .NET run it. Now, I'm going to show you a little bit of this with .NET 6 today, so we can see some of the new features that have come along as part of Blazor here. So the machine that I'm running on, this is actually a Linux machine running Kubuntu Linux. It's running KDE on top of Ubuntu. So let's head over and take a look at our first Blazor application. And we're going to take a look at some other demos along the way here. So I am going to, let's go over here, and let's open a terminal. So I already have .NET installed here, so let's go into my dev folder, and we're going to create our first application, .NET New, Blazor WASM, and let's call this DEVint first, -O, there we go. So this is creating a new Blazor WebAssembly application and writing it into that folder. So I'll go into that folder, right? And let's just .NET run. Just run the application and see what we get, and let's peel this back a little bit and dig in. So let me open browser for this. There we go. No, you're not gonna. There we go. Localhost 5000. And there we go, hello world. And I've got an about link in the top left. I've got a counter nav item on the left, a fetch data nav item, and I've got this little survey thing in the middle. How is Blazor working for you? Please take our brief survey. And there's a couple things going on here, but this is all running in the browser. Look at this. I hit F12 to bring up my developer console, and it says Blazor loaded 8.6 meg resources. 8.6 meg just to run hello world. But what it's doing is it's downloading that .NET runtime. It's downloading my application and putting that into application, it's putting it into local storage here, and we're able to see it right there. These are all the things. Now, when I'm running in development mode, it's delivering all these DLLs because it's running locally. When we publish and we ship these out for anybody on the web to interact with, it's actually going to link them in tree shake, so it doesn't send all of the content. So you don't see 8 meg loaded out there. However, I tried taking the Pepsi challenge and comparing to other websites. Well, how does 8.6 meg compare to other locations? And I went and looked at places like YouTube and Twitch that are doing a lot in the browser. And it turns out that they load a little bit more than that in JavaScript libraries when you first go to their websites. And they load it every time. They don't cache it like Blazor does. This is sitting in local storage. It won't ask for it again. And I can actually see, right, it loaded 8 meg from cache, loaded 0.04 meg over the network. So it didn't go and load all that content again just for opening the application. This is a good thing. This means that it's going to load and manage and behave properly for us. How we doing over here, Teams folks? We all right? I'm looking for one of my techs. I don't see anybody. I'm going to assume we're doing okay. So there's a couple things going on here. Let's look at the counter first here. This is a very simple, click this and it increments. Big deal. So what? What's it doing there? It's incrementing this number, but it's doing it with C# in the browser. I've loaded these DLLs, right? And if I open this back up and show you the list of DLLs, right? Look, Microsoft ASP.NET Core, Microsoft Extensions, C#. It even loaded some components to Visual Basic here. But if I keep scrolling down, it's going to stumble into, right? Look at all these system runtime, system security bits, threading, and .NET WebAssembly. Come here, you. Did I miss it? Did I miss it? I should see DEVint in here. There it is. DEVint first DLL. There's my application, and it's only 17K. And that's running out of it. Let's go over and take a look at the code that's actually driving this. So let me run tmux so I can put this here, and we'll just .NET Launch over there, and over here, we'll open Visual Studio Code. So there it is running on the left. Here's the application. If I go look at that counter, here it is. Okay, let's close this. So I have this little increment count method that is called, and it fills in that current count right there and updates it. And I have on my button, I have this little onClick method, and that looks like a JavaScript onClick. It looks like a JavaScript onClick, but it's got the little @ sign in front of it. The @ sign tells the Blazor runtime, this is C# code. This is a .NET method that you're going to execute when that button is clicked. And it's going to execute the method increment count. And increment count is right here. Okay, so there it is, and when I click it, it does current count +1, and it refreshes that number. Now, one of the features that we've been touting that we say is so great that's coming as part of .NET 6 for Blazor developers is this feature called hot reload. Now think about it. This running in the browser is, it's got a DLL there. For me to hot reload something means I need to shut down the application, patch that DLL, and restart it. Well, we can do it without patching the DLL. I will save, and it'll refresh. You see a little thing popped up there, updated the page, and now it counts by files. And if we go back in here and change this to, let's make it really dramatic and go by 100, And now it increments by 100s. So the simple updates in here, right? Save and it refreshes. So now as a .NET developer, right, as an ASP.NET developer, you're used to, I've got to rebuild the application, I got to wait for it to load, right? And the whole edit and continue experience just was lost for how long? Now, right, I have .NET Watch running in the background on a Linux machine running Visual Studio Code. I did this on purpose for these demos because I wanted to show you that this is not just a Visual Studio thing. This is something that everybody can do, Windows, Mac, and Linux, and build your Blazor applications and be successful. I'm running in Firefox on a Linux machine. There's no Microsoft tech here except for .NET, okay? So these are things that make us as Blazor developers, they empower us, they enable us to do more, to go to different places. And this application doesn't have any moving pieces on the server. These .razor files are my Blazor components. They're my pages that specify here's what you're going to present when we navigate to the various locations. So this @page counter you see on line 1 here, that tells the Blazor runtime, you're going to display this content when we navigate to /counter. But pages in Blazor are also components. And a component in Blazor is something that we can reference, that's another .razor file that we can reference with a tag. So this kind of makes sense. I've got a survey prompt tag here. Let me bump that up. So I've got a survey prompt tag, and there is a survey prompt .razor over here. So I have a tag that has the same name as the .razor file. And when we look at that, here's that div that says, please take our survey and tell us what you think. This is garden variety HTML, Razor. We're used to seeing this. We know how to do the pivot back and forth between HTML and Razor syntax. We already know how to do that because we've been doing it for 10 plus years. But now we're taking it a little bit further by making this .razor file, which has a little bit more features than what you're used to seeing in Razor templating. Now we can do things like add this code block that we see down here on line 12. Now we have the ability to, instead of adding functions like we did in Razor templates for ASP.NET Core, now we can add additional code that enhances the behavior of the component. So here we've added a parameter with that parameter attribute above this. It's a parameter for this component called title. It has get, set, and string. We're used to seeing this. It's a garden variety. It's a typical C# property. But what we can do with that then is over here on the index page, I can now apply that parameter as a tag attribute. I can fill in some content that gets passed in as a property, and when it gets rendered over on the survey prompt, it places that title right there on line 3, outputs it, right? And that's something you would kind of expect. That's something you're familiar with in using Razor. So let's take this a little bit further, right? That's my survey prompt. I mentioned that every one of these is a, every one of these .razor files is a component. So let's remove that. I'm gonna go back to my home page here, save, and it's gone, okay? Do I have auto save turned on? So I should be able to change this, and it'll automatically refresh and update because I have auto save turned on. I'm not even myself, Control S, working on this. So now I can add that same counter component that I have counter over there, and it appears on the page, and I have this with the +100 sitting there. I can go further and wire up a parameter over here so that I can change the increment up, right? So let's set this up as, right, parameter I'll use the public int, I'll call this increment, get set. Let's hide this. There we go, it recompiled properly. I'll take that increment and I will default it to 1. And instead of plus minus 100, I will say plus equals increment. And now if I go over here, this isn't working. Why isn't it working? Increment equals 1. What did we do? So what we can do is we can also force the reload. So it loads up brand new content. Let me make sure. Yeah, there it goes. Now it's counting. So let me go back to here. And if I go to my index page, I can extend that counter now to say increment equals. Now let's add the 100. Refreshed. And it updates. So I have this very rich parameter feature that I can use to pass data back and forth between components. Now, those that are using JavaScript and Angular, Vue, and React, they use fetch to go and get data from various microservices for interacting with cloud services, right? You may want to use Azure Search or Azure Storage to store content that you want to fetch and present on screen, or you want to execute a search operation, bring back the results and paint that on screen. Well, the fetch data sample here shows this very basic interaction that will allow you to get data from somewhere else and paint it on screen. And as .NET developers, we already have a component that does this. It's the HTTP client. So, just like we can in ASP.NET Core, we can use the inject directive that we have there on line 2 to inject an HTTP client into our Blazor page, into our Blazor component. And our code then can go out and get from some service, right? It's going to go get some JSON and return it as an array of weather forecast items. Now, the weather forecast is this little class right here. So we've written a class that lives inside of a Razor file that runs in the browser. We're going to go fetch data from this .json file, put it into this forecasts array that we see on line 38, and there's a little for loop here that outputs the content on the right. So we have a way to go fetch data, fetch it in whatever format you want, format it however you want because you have access to all of .NET. JSON is a handy format, real easy to work with, and paint it on the screen. Make decisions what you want to do and make it appear appropriately. That's not bad. We can start to get really creative now. So we have some samples out there, some other applications that we've been going through. There's a great to-do list example available for you out there that you can take a look at and wander through and see how things fit together. But I want to call back to the Blazing Pizza demo that's part of our workshop, and we gave the Blazor workshop yesterday here at DEVintersection. Let me head over to the console, and I'm going to go start that application. So this is available on our GitHub. There we go. Yes, .NET run this one. There we go. So it's not just a sample application like this, but we can do pizza shop. It looks and feels a little bit like a typical storefront you might go to online in order to order pizza, order something from DoorDash or wherever to be delivered to you. So I can go through, and I really like pepperoni pizza. If I'm going to order this for my family, let's make this a little bit bigger. And I like to put some bell peppers on that also. All right, and we can place that order. It appears over on the side. I can place that order. It'll prompt me to log in. We have security available for Blazor. It works all the way through from your ASP.NET Core server into Blazor. We can use OIDC if you want to authenticate that way as well. So let me log in as me. Let's see if I remember my password. See if I remember my password I set up for this. Nope, I didn't. I'll give it one more chance, one more try. Nope, I forget my password. That's fine. Register as a new user. Sure. I'll log in as this. There we go. It's not wired up to email, so that's fine. Yay. And let's log back in. And there we go. All right, try that again. So I wanted to get a pizza a little bit bigger and presenting content using a JavaScript map component live in the browser. So this is not just simple demos. There it is, getting closer, right? We can do a bit of tech with this. We can actually get outside the box here and build full web applications with this, okay? There we go. Delivered, and there's the delivery location. Why am I getting... I'm not sure why I'm getting that video blip. So, all right. Those are the typical examples that we'd like to show about this. We also have the ability to do static websites. I mentioned, right, we can do, because this is all DLLs being shipped down and running in the browser, we can run this on top of just static HTML. We don't have to have things running on a server. You may want things running on a server, so we can do that with Azure Functions, right? Those are very small little blocks of code that sit on the server, execute, maybe query a database, return some data, paint it on the screen, and then we're not managing servers at all. We're now just managing the application that runs in the browser. So I wrote a little application that shows this off because I thought it would be something fun to do. So you might not know this, but I like hats. I really like hats. I really, really like hats. I've got more than 120, 130, and I wear a different one on every video stream that I do. And I've loaded about 60 of them onto this website with a little bit of CSS. But this is, it's just a website that shows some of the hats. But this is all taken, presented, and running native in your browser. So I can go up here and I can search for, right, I have a handful of Penn State hats. So that search is all running in the browser, formatting and relaying out the screen. It's doing a query back to an Azure function to go get the data out of the database and present that information. So I'm not actually running a server here. Once that data is delivered to you, it's done. It doesn't go fetch anything from the server. I load up those images from Azure Storage, but I'm not going through all of this challenge of loading up where all my data is every time, right? I load it once, it's sitting here in JSON, right? Here, there's a SpaceX hat, and I can search for and bring that up. DEVintersection 2019 in Orlando. I went out to Kennedy Space Center and I got this hat. So that's easy. The source code for this is available if you want to check it out, and I want to step through and show you just one or two things about this real quick. This is Fritz.hat collection. So there are 3 parts to that application. There's the API that runs on the server. There's the client app, which is the Blazor application. And then there's the shared content that travels from server to client, my hats. So if we take a look inside that shared folder, I have a hat object. And the hat has a name, a description, when it was acquired, and the image URL. But on my API, I have just an Azure function that sits out here, has a database repository, and all it does is go into that repository, get the hats, and return them. I have one function that runs on Azure. This costs me nothing to run. The static website itself costs me nothing to run. On a basic service, it's free to run this. When you start to hit a significant number, like millions of requests for the function, then you have to pay a little bit. But just to host this and run out there and support Fritz's hat collection costs me nothing. And it's a simple website, and I've built it with Blazor. It all runs in the browser, and I don't have to think about managing servers and how things are going to run in the browser, because it uses the exact same programming language, the exact same framework front to back, in the browser, out of the browser, on those Azure functions. And I'm referencing that same hat object in both locations. So now my business logic, my skills as a .NET developer become much more powerful, much more portable to take to other platforms. And we're going to see more about this as we get into .NET MAUI coming up in the fall. With .NET 6, we're going to be able to take our Blazor applications, our Blazor pages, and copy them into a .NET MAUI application, and it will compile and run those natively on Windows, Mac, iOS, and Android. So it's very important that if you are a web developer, check out Blazor, get involved here, get a little bit into it. This was a simple website that when you look at the client, it's silly how simple this is, because I have an index page here, and all it's doing with its collection of hat objects is saying, for each hat, format the hat on screen. I wrote a little hat UI component just so I could show how easy it is to build a little component that knows how to format a hat object with the Bootstrap card UI. So I put the name of the hat, I put when it was acquired, and I put a little bit of a description. And I can even put a footer on there if I wanted to. And I think I did put a footer on this so that you could see. I started putting, yeah, there we go, some acquired dates on these. I have a super C# hat there. My Blazor hat is down here somewhere. There it is, Blazor. April 2019, I made that hat. So this is easy for us to do. We know how to do this. You know how to build HTML. You know how to work with Razor. This is where you want to be. Not in my hat application. This is a simple application. But these are the things that you're going to benefit from learning looking forward at the next 12 to 18 months of .NET and where you want to take your career. So I have a couple resources for you as we wrap up here. The WebAssembly specification, if you want to dig in and learn more about how WebAssembly runs, why it's so good in the browser, check it out at webassembly.org. The awesome WebAssembly list, where you'll find the demo for Doom that I ran in the browser, because I know you want to run this on your phone, because Doom runs on your phone in the browser, okay? I did this with Safari. I did this with the Diablo demo. The Diablo demo is at Awesome Blazor, but you can check those out on GitHub. Get Blazor at blazor.net. And you can install .NET 5 SDK and get that running at get.net. All right. How are we doing on Teams? I want to make sure that the folks that are watching remotely are able to ask some questions. If we have any questions in the room, I'll take them now. I'm trying to check in here and see where we might have some questions. There we go. No questions in chat. Okay. Everything's quiet on Teams. Anything here in the room? In the middle here. Sure, the question for everybody to be able to hear is, when I was showing the counter sample, I had a little bit of a caching issue there, that it didn't reload and present properly. So to be clear, I'm running .NET 6 Preview 4. I'm literally showing you bits that were released 3 weeks ago. So some of the things around the hot reload aren't perfect yet. So it wasn't refreshing the screen completely when I ran that. So if I go back up here, where was it? DEVint first, and if I .NET run this, so I'm not watching, right? .NET Watch will run and execute your code and re-execute your code every time it changes. So the counter example here was caching for me, because the way that .NET Watch runs, it keeps a lot of that code running in the background, and it is just swapping out bits. So having to restart the server because I'm in development mode is what happened there. So thank you for the question. Exactly. We're getting there. It's growing. So there was a question over here on the right side. Yes, sir. Yes. So the question asked is, when I was showing the property that we were passing in here for the counter, I was passing in over here in my counter example, I just passed in an integer here for a parameter. And in the survey prompt, we're just passing in a string. Can we pass more complex objects into our components, into our Blazor pages? Yes, we can, is the answer. If I head back over here, and I'm gonna go back to my hat example. See, I like hats for a reason. Check this out. So this is that hat UI component. Inside my hat collection website, each one of these cards is a hat UI in Blazor. So this is the source code to that component. And inside here, the property that I'm passing in is a hat object. So I've got my domain model. It sounds weird, domain model, and it's a hat. Okay. But I'm passing that more complex object in, and it's using that and presenting it properly on screen for me.
Hi, Caruana. Welcome to Orlando.
Hello, Scott. How is it there in Orlando? Thank you for having me.
I don't know if you can see, I'm so sweaty. It's so humid here, but I love it at the same time.
Right?
I think you just time traveled from another session that was like right around the corner to hang up on that Teams call to then come join us on this Teams call.
Yes, that is absolutely true. I was teaching adoption best practices for modern work, and that was very fun after my keynote this morning. So I am busily hopping around the conference right here from the comfort of my home in Seattle, Washington.
Nice. Well, we decided to step out into the hallway, so you're going to hear a little bit of background noise, but we're just right around the corner from where you were with the rest of the attendees. So we appreciate you joining us. So on the agenda today, we just have an interview, sort of get to know you better and then figure out what we can do with developers on some of your content. So let's learn a little bit more about yourself first. Tell us who you are. This is obviously a new audience than what you just came from. So let's hear that.
Okay, no problem. Well, it's great to be with everyone. I'm Caruana Gatimu, and I am the principal manager of the customer advocacy group in Microsoft Teams Engineering. And I have the privilege of working across Microsoft 365, driving adoption, releasing cool tools, coming and educating customers about how to get the most value from Microsoft 365. And I have a definite place in my heart for the developer community. I am a developer by trade. I don't get to do it nearly as much as I used to. And I have a real love for the low code, no code entry point that we're really focusing on in modern work right now. And so there's a lot of fun things happening in the developer space, but across Microsoft 365. So I get to do all that good stuff.
Yeah. There is a ton of space. So for those of you that don't know me, my name is Scott Kate. I'm live in Orlando with Learn TV. We will be answering some questions if you have inside the chat on Learn TV. So please let me or Caruana know. I'll be monitoring those and we'll see if we can answer them along the way. But similar to you, I have a developer background, but I don't have as much of the integration stories as a background that we're going to talk about today. So I hope to both educate myself with some questions. Hopefully I don't embarrass myself asking you things I'm supposed to already know. And then really bring a developer perspective. You know, I'm familiar with Azure. I know what app service is. I know how to deploy apps and sort of write my own code, but that's where I manage everything. I've dabbled a little bit with Logic apps, but I haven't done anything with Teams and some of the great things that I've seen you talk about with like the interactive cards and, you know, how to get started with that. So I'm really excited to go down that road.
That's good. And you know something, this is for you and the audience at large. There are no dumb questions because I tell you, I do this every day and it's really difficult to keep up with all the new things that we're releasing. And so, you know, that's really the purpose of like Learn TV and also our community so that people can come and keep asking questions because every time you find a new scenario you want to improve with something like adaptive cards, like I'm going to talk about today, you're going to come up with some questions for sure.
Yeah. And because I haven't done it before, I sort of feel a little exposed. Like,
yes,
like,
it's nerve-wracking.
I'm not the expert you are, so I'm here to learn. So with all of that, what is sort of the, you know, one of your favorite developer things that you're working on? Where do you want to take us today?
Oh, I want to take you to something that we call the Extensibility Lookbook. And this is a fantastic place to start, especially if you're new, and how to think about changing your business processes and your apps, especially using Microsoft Teams. And so this is on adoption.microsoft.com. My team and I run this, and we really bring together tools for developers and business users and IT professionals to get more out of Microsoft Teams and Microsoft 365. And so the idea here with this gallery is to give you inspiration. And that's really the theme of our site, inspiration to execution. You hear a lot of cool things at Microsoft, but how do you actually do them, right? We want to make sure that you've got those snippets that are available.
These are great to fire some cylinders to let me start thinking about what's possible. You know what the hardest thing for me is? Starting from a blank slate. It's always easier for me to look at what somebody else has done and then either learn from that or even, you know, Stack Overflow, copy paste, and then adapt to the problems I'm trying to solve. So having these online, I'm actually sharing the same screen with you. So let's go through a few of these.
Yeah, they're really great. And so we've organized them in 3 ways: by product, by the kind of experience that you want to change, documents or conversations or whatever, and by various scenarios aligned to business processes. And so however you're coming to this, whatever way you may be coming to it, is really important. I'm going to go back to products for a minute. And because I want to go into something that you may have heard about a lot at Microsoft Build, and that's adaptive cards. So adaptive cards are essentially, have been around for a while, but we're continuing to invest in the way that they work across different workloads and operating systems. And from here, you'll be able to see some examples of how adaptive cards work. But even more important is getting to the sample gallery. The sample gallery is super important, and it actually goes through another site that's called adaptivecards.io. And this is a great getting started site. And this getting started site gives you all of the versions, the visuals about, how these things work. And up here at the top, it takes you right to the sample gallery. And I love this sample gallery because the sample gallery will show me all the examples of the types of adaptive cards that I can build. Right. And it actually shows me the code and I can try it myself. Right. So this food order one is pretty fun.
Already right at home here. I can see there's some JSON. I can start to feel the idea that somewhere there's a server, whether that's serverless or logic apps or even my own server, somewhere we're asking questions back and forth. And this is sort of the payload that's being transmitted like across the wire. And then it's being rendered as that adaptive card inside some other client, like a text message or Outlook or something.
Exactly. And that's a really important point, Scott, because you're going to leave the rendering to the client application. You're not going to have to deal with that portion of it, because whether your user is looking at it in Outlook or Teams, or as you said, a text message or embedded on a website,
right. Light mode or dark mode.
Yeah, whatever, that experience will handle the rendering, and you are basically focused on the actual interaction and the experience. So I was talking about this earlier today in my keynote, and some things really come to mind really easily. Like obviously there's things like food orders or weather controls and what have you, or even expense reports that you can do. Yeah. But there's also things like DevOps scenarios. What if it was an adaptive card that was alerting you about an event on Azure, that there was an interruption of service or a degradation of service? Or that a customer had, interacted and said that there was a service issue, right? The most important thing I ever did as an engineer, as a service engineer, was know when there was a problem and fix it. What'd you say, Scott?
That's a big statement. Are you sure that's the most important thing?
Well, actually, yeah, because I need to know if there's a problem so I can fix it before my bosses do. Maybe the most important thing was I learned how to live on coffee. I'm not sure.
There you go. Yeah, I've built some of these really big apps, and as you build a big software app, you've got the right architecture so that you know how to deploy and maintain the app. But then there are all these little popcorn features, like little features that are off to the side. And I sort of imagine, how could I let the user interact with just that little popcorn feature without having to actually be in the app?
Yes.
But somewhere, and this is where I'm asking a question back to you, somewhere there's like identity, and the person interacting with this card has to be the person that's interacting with the app. So how does that talk to each other?
Well, the authentication process again is handled by the client. So right. So the client is actually handling all the complications that identity brings to us as developers. And another thing I want to call out to anybody who's new, right? Maybe you're new to this space. This might be the first time you're watching Learn TV. This is a great place for new developers or low-code, no-code developers to get started. You can start to get comfortable with what JSON looks like. You can start to understand how to read code like this. It doesn't have to be intimidating. Like some of the other things can feel really intense to get started with, but this is a great place to do it. And we have new templating that allows you to create templates for these types of cards so that then you can reuse them in different scenarios. That was just updated in May. And so if you have been using them for a while, you should check out the updates because the binding method has changed a little bit. But nonetheless, the template idea is really important. And really think about the kind of changes you can make. If you get some feedback from your users that they don't know how to order a new headset, you could start with this food order adaptive card, change the language, and you can try it yourself right here on the web and change the language and see how they could order a headset or a new laptop or something, and show that to them in a chat in Teams, and off you go.
I love that. Try yourself. I'm actually cruising through there. I don't know if you can see.
Look at you.
There's one on the side, and you can sort of see an agenda, like a bus stop, and you go from Redmond to Bellevue to Seattle, and you can do stops. So, I mean, these cards are much more flexible. Like, I have to admit, when I started Adaptive Card, I'm thinking, how can I ask the user some yes/no questions? Like, is this good? Are you going to approve this? Or, you know, are you going to be on time types of questions? But this is much more rich than that.
Oh, yes, absolutely. And it's just the beginning. And so also you can think of adaptive cards as they connect to the Power Platform. So think about taking the responses from an adaptive card and kicking off a workflow in your organization. And this is the thing that gets me so excited, right? I'm a business process engineer. That's what I've done forever. I really love to be able to automate processes and structure data. And also then I can control identity and access and analysis of that data. And that really gets me up in the morning. I get excited about it. So if you take that response from that adaptive card, do something with it, right? I mean, certainly you can do that one little thing, but think more broadly once you have Power Platform involved, the kinds of further actions that you could do with that data.
Right. Yeah, I've done a little bit with Power Flow, and now the gears are starting to turn, and I can imagine, you know, I might be able to do some of these popcorn features of my app without actually even touching my app, because I can fire off either an Azure function or something in Power Flow, or maybe vice versa. Those two can sort of work in tandem. And so the one thing that I did in Power Flow was automatically create some calendar appointments based on meetings that we're doing. You know, Learn TV has all these meetings all over the place, and we've got people all over the world like yourself dialing in. And so, you know, automating that calendar appointment, the beautiful part was I didn't have to actually deploy any services. I did 100% of everything right through the portal. So super excited about that and how these cards. Now, you mentioned also that the card renders inside the client. My head goes to Outlook because I get a lot of email, and inside Microsoft, we have the ability to approve expense reports now. In the old days, it would say, you know, do you approve this expense report? You click a link, you go to a website, you log in, you see the details, and you click approve. But now, right inside my email, I just say approve. Like, it's one button, and then inside the email body, you get the little spinner, and then it just says approved. So I wonder where else are these cards?
Well, basically they can be anywhere that you want to put them, but certainly in Outlook, certainly in Microsoft Teams, certainly on the web. And think about what that means from a mobile experience, right? Yes, of course, on your desktop, you can go and interact with that adaptive card inside the Outlook client, but you could also be using OA, you know, Outlook on the web. You could be using Outlook on your mobile device. And it's really important to think about enabling frontline workers with these kinds of capabilities. There's many people in our organizations that never sit at a desk. They don't have that experience. They're not information workers. So you want to be able to extend your capabilities into the hands of the mobile device that employee has. Here's another thing I want you to think about. What if you work for an insurance company and you're an adjuster and you want to go out into the field and take pictures based on a claim a customer has done? You can use an adaptive card to take that media and send it back into the office and attach it to that claim record.
Right. So I was thinking adaptive card is really just, you know, elementary input of buttons, yes or no. But you're saying I could do a whole bunch of more data collection with the adaptive card.
100% I am. And then I'm also saying that once that happens, then you have PowerFlow do other work to it based on the information that you get. And so this really transcends the ability of what you're doing in the client. And if you put it together for some of the other extensibility capabilities we have, think about telehealth. Like what you mentioned earlier about Learn TV scheduling, for me is a telehealth scenario. right? I have doctors who need to schedule automatic appointments. They also want video and chat services in a branded experience. I can use the extensibility components and adaptive cards and other things to build that experience, right? And so you're not limited by the user having the client. The capabilities can come outside the client and live in third-party applications that are custom developed for industry and business scenarios. And again, like this is the thing that gets me up in the morning. Like this, people think that I just love the adoption, but I actually love building this stuff because it's so much fun and it's very creative. To me, it's creative to be able to think of how to do this stuff.
It's super creative because you're really only limited by your own imagination. And the thing that I'm most excited about, particularly with the work that I've done in the Flow engine, is I don't have to host any of the servers.
Yes.
And so what that means is, and there's still CI/CD pipeline, so I can still store some of that really advanced logic inside GitHub and then deploy it. But I don't have to do that. I can actually just use the portal and get a really long distance towards the solutions that I'm trying to build for. So let me ask you this: you talk to people all over the world. What's one of the more exciting use cases with these adaptive cards that you've seen, where you had like an aha moment, like, oh, I didn't think we would do that, or somebody who's doing something in the field or on the road in mobile or something else. Can you think of anything there quick?
Oh yeah, I can think of a lot of things. I had the pleasure of being the lead of our COVID response team during this pandemic for Microsoft Teams. And I'm not necessarily the natural person to think of taking that role, but I have a lot of experience in emergency management and I'm really good with modern work tools. And so I kind of ended up being that person. And I had the privilege of watching people use our technology to do really important work in ways I never would have thought we did it. And so much of the innovation came from outside Microsoft in the partner community, individual developers in different companies doing things to get supplies to people, understand what was happening out on the ground, mobile hospital deployment, and now, of course, COVID vaccines. Right. And so, while I think of these tools in very business-centered ways, there is absolutely no doubt that when things are really important, like who's getting the COVID vaccine and who isn't, or being able to gather data from people in your community about the impact of a variety of kinds of things. Because remember, COVID isn't the only thing we've been dealing with. There's been other types of natural disasters and other issues around the world. And so gathering data from the people in your community is really important. And so I've been really blown away with how creative people have gotten in being able to hear the voice of their constituents in a particular community by using these tools. And the fact that they're available across Android and iOS and Windows and Linux, I mean, it really democratizes your ability to get data.
Yeah. Okay, well, we've got a few minutes left. I just did a search for developer program Microsoft 365. Oh, yeah. And that took me into sort of how to get started. And then I didn't know that there's a developer M365 account. So, I'm internal at Microsoft, so I sort of take advantage of all the things that we have available as employees. But I signed in with my personal account, and I actually can have a free M365 Scott Kate account, and I can do everything. But I got into the fine print. It's good for 25 users, but it doesn't last forever.
Right.
It lasts forever if it's active. So I thought this was really good of Microsoft because, you sort of all have these ghost accounts out there that you've set up and then forgot about. This automatically renews every 90 days if you're actively using it with developer stuff. So it's not for production, but I can do all this stuff for free. It literally cost me $0.
That's right.
It was instant to set up. So if people are interested, that was, once again, do you know the URL for that, or? I threw you on the spot.
Yeah, no, this is developer.microsoft.com, and you can get to the Microsoft 365 developer program from there. But you did the right thing. Search for Microsoft 365 developer, and you'll get right to that homepage. And this is really important. It's really important to make sure that you have a sandbox like that. Nobody wants to learn in production. Nobody should be. You want to make sure that you have a place to test everything. and that you feel comfortable deploying things. And oftentimes in your own company, you're not an admin of the environment. You may not be on the Azure subscription. So you want to know how these things work. So go to developer.microsoft.com, sign up for that. And Scott, you're so right. As long as you're active, you'll get that free forever. Plus, you'll get great information from the developer program. And we work really closely with them on adoption.microsoft.com to make sure you get all the information about once you build something, how you get people to use it. Because sending an email is not the way.
That's right. So many of the times we miss email or don't look at email, but a DM inside of Teams or text message, that really gets my eye. So one of the things that you said earlier, since these adaptive cards can render inside Outlook and Teams, but also have a web presence, the try it now is really strong. Like I changed the zip code in the map. There's a map adaptive card and I just changed the zip code to my house. And like the map just zooms out and it shows the property on my house exactly like you'd expect it. I didn't have to install anything. I'm literally just doing it right inside the portal. So adaptive cards seem like they have a huge future. So we just have a few minutes left here. Anything you want to close with?
Well, I mean, I really want to thank you for having me on Learn TV today. I want people to get started. Go out there and visit adaptivecards.io, visit adoption.microsoft.com and our extensibility lookbook, get inspired, and then get executing. It's easier than ever to get started with this stuff. Don't let it intimidate you. If you're new, hop on in. And if you have questions, visit us in the Microsoft technical community. We are always there to help. And, you know, this is what we get to do. It's a privilege for us to be able to help folks and talk about these things that we're really excited about. But new technology is only as powerful as the people it's designed to help. So make sure you have a solid really business case for the work that you're going to do. Who are you helping? Whose experience are you improving with an adaptive card, right? Or anything else that you're going to use across the Microsoft ecosystem. So always have your end users in mind and know what it is that they need, and you'll do great.
That's great advice. All right. Well, thank you so much for joining us in Orlando. I look forward to someday being inside the studio with you. To give a quick little fist bump there. Thank you to everyone in the audience of Learn TV for joining us. We'll see you next time.
See you later.